Hey guys, welcome to the studio. So before I begin this build guide, I want to announce that I've started a Patreon. Yay! Okay, so on my Patreon, there will be a variety of reward tiers as well as rewards such as free STLs or free 3D models from some of the 3D models that I've designed in the past. In addition, although this 3D model will be released onto my CG Trader account, it will be a partial release, as in certain pieces of the whole 3D model will be missing. And in order to actually gain access to those 3D models, those will be limited to a certain tier within my Patreon account. Overall, the cost of the 3D model for this build or any other future insane build is going to be a lot more expensive than the other 3D models that I've created in the past. This is primarily because creating any insane build takes like 5 times the amount of effort as any of the other 3D models that I've made. And it's a whole different discussion on why I'm doing it, where I'm doing a partial release and then making the other pieces exclusive to my Patreon members. But I'll leave that explanation in the description below. Anyway, onto the build. All right, first things first, some tools that you'll need. Obviously, you're going to need a 3D printer, but you're going to need a large scale 3D. Quite a few of these pieces are able to be printed on a 200mm cubed 3D printer, but some of them you're going to need something that at least has a height of 350 or 330, around there. Because although you can slice some of the pieces into smaller chunks and print them onto smaller 3D printers, because of the weight of the head, it's going to need a lot of that sturdiness of being 3D printed in one chunk. That being said, if you really want to slice it apart into smaller chunks on your own free time and then just glue all those chunks together and then just try it out, I wouldn't fault you for trying that, so go ahead and go for it, I guess. Now, aside from your basic 3D printer gear, you're going to need some epoxy resin. Very specific connections that are a part of the head of Specter the Unchained's weapon pretty much requires epoxy resin because of the strength required to keep everything intact. You can try a bunch of super glue, but super glue is kind of expensive per volume whenever you buy it, and a lot of super glue releases fumes, and if you're using that amount of super glue, you might as well just splurge and use some epoxy resin instead. Another thing you will probably need, especially if you're going for the motorized version, is some JB Weld. This is pretty much like epoxy resin, except it sets very, very quickly, and it releases like this pretty awful smelling odor. So I highly recommend you use this in a well-ventilated area. It's pretty much used to fuse some of the metal components together, specifically the shaft of the motor and the flanged coupler that you will be using. Speaking of flange coupler, you will need one of these flange couplers. The particular flange coupler that I bought are these right here. You could use other versions, but the measurements and dimensions that I used for all the adapters that I 3D modeled are pretty much based off on these measurements. Another thing you will need is a DC motor for the DC motor version. The tolerances I used for the neck are pretty much based off of this Geartesian DC motor. The 50 RPM version is pretty much as fast as you need. All right, back on the topic of epoxy resin. Aside from your measuring cups that you will be using, I like to make use of these 1mm plunger syringes. They're very useful for both stirring the resin and hardener together, as well as drawing it up and precisely pouring it out. Another thing you will need is a soldering kit for the DC motor version, as well as spare wires, and you will also need some of these direct current connectors. Another thing you will need is a size 10/24 machine screw. This is 1.5 inch, but for this 3D model, you're going to need at least 2-inch length screw, as well as a 10/24 size nut. All right, onto the 3D model. All right, so this is staff section 1. Staff section 2, and as you can see, there is a hole for a wooden dowel for staff section 2 and above. The wooden dowel that I am using for these measurements are a 1 1/8 inch diameter. Now, as you can see, the wooden dowel does not go all the way down into staff section 1. That is okay. Staff section 1 locks into place into staff section 2. Then at this point, you would pretty much turn it upside down and then apply epoxy resin to these little inlets right here. As you can see, there's spaces here. That means that the epoxy resin will then bond staff 1, 2, and the wooden dowel. And then after the resin has cured, Then you would continue with your assembly. Here's staff 3, here's staff 4, here's staff 5, here's staff 6. I would recommend spray painting staff section 6 separately before you begin assembly. Since this section has that copperish color to it, it's a good idea to do the spray painting ahead of time before you're forced into accidentally blasting other sections with copper. Here's staff section 7. This is going to be a large piece. I recommend 3D printing this piece upside down. Now we're going to go back down and show you guys wheel L1. This is the left side of the wheel. This is wheel L2. Here's wheel R1. And here's wheel R2. Like I mentioned in the last video, these can be 3D printed and then they're able to slot into this notch here. That means that staff 3 needs to be oriented in this manner. And then the wheel 2 segments can very easily slot over these bridges of the staff 1 section. All right, moving back up, we are moving on to neck 1. This is another large piece. This is another large piece with a lot of overhangs. And as a mental note, whenever you're throwing it into your slicer, if you see any circles like this, go ahead and add a support blocker because it's really not needed to have any supports here. I would also recommend 3D printing this section right here and staff 7 in PET G if you are able to. Either that, or if you're only printing it in PLA, then print it at a higher density. I would recommend roughly 40% infill because these two segments are pretty much where your stress points are going to be at. In fact, with neck piece number 1, maybe even bumping it up to 50% infill cubic if you can. This is neck 1L, pretty much some of the side pieces that are attached to neck 1. This is neck 1R. This here is neck 2. Tolerances are pretty tight, but it should be able to very easily slide over and into neck 1. And at that point, it's just a matter of applying quite a bit of super glue. All right, this is neck 3. This is a very large piece, a very large piece. So once again, you're going to need a large 3D printer. This is the back copper shaft. As you can see, neck 1 is able to slot into the copper shaft. Here's support bar L1. Here's support bar L2. I just separated these pieces into 2 pieces. That way they're smaller and are able to print on smaller 3D printers. It's pretty much just an aesthetic piece. They don't support anything, so it's okay if it's off by a little bit. And if you can't quite get it to fit into the neck 3 piece, then you can just use a heat gun to blast it. Here's support bar R1, support bar R2. Here is the back head 1. Now, I kind of did a small screw up. As you can see with the way in which these are angled, they're angled, which is not good for 3D modeling and assembly, because every single piece, whenever you fit them together, they have to be able to fit in like straight on. No pieces can be angled. And so that's like a principle of just 3D modeling and assembly that I violated because I'm still learning. So yeah. I did make adjustments to make it a lot easier, but if you're still having difficulties, then just blast it with a heat gun and then make sure that it fits in. And then at that point, apply some generous soup. Here's back head 2. Once again, another large, intricate piece. There's plenty of surface area between back head 1 and back head 2, so you should be fine there. Now, if you look here on neck 3, I have this negative cylinder space here. This is pretty much where the DC motor is going to go. And then if you look inside, there is a hole here. And this is where the other end of the tunnel goes. This is pretty much where you feed your wire. The wire will feed down. You will then solder the connecting piece, and then your battery will sit around here somewhere. All right, and that is the staff section. Before we move on to the head section, I would like to touch on the length of the wooden dowel that you will need to use. So if I go ahead and create a line and measure the total length, you will need approximately 110 centimeters length of the wooden dowel. I would actually recommend cutting it a little bit shorter just in case you accidentally make it a little too long and you've already glued it in place. One last thing before we move on to the head section. So staff number 6. This segment is pretty much used for detaching the staff into separate pieces. That way you will be able to more easily transport it, because this thing, once fully printed, is going to be very long. It's roughly 6 feet, I believe. So as I describe this next section, pay attention, because this is how it's going to work. If you intend to ever transport this prop and need to split it into multiple pieces, then I would recommend cutting your wooden dowel at approximately 90 centimeters. What that will result in is the wooden dowel jutting out from this staff number 5 past staff 6, roughly halfway into staff 7. And then as you assemble it, you will pretty much do a dry fit of staff 6 and staff 7, and then apply super glue to staff 6 and staff 7 on the outside edge here. That way you will fuse those two pieces together. And then another thing you will do is take a drill and drill a hole straight through this guide hole that I've already 3D modeled. As you do that, you will drill a hole through the wooden dowel, and that way, once you finally get around to using your nuts and bolts, the nut and bolt will go through staff 6 and through the wooden dowel that is attached to the lower half of the staff sections, and then it will thread into the nut on the other side. What that will do is secure both halves of the staff sections together, and then when you need to put it away into storage, or whenever you need to take it apart for travel, you can very easily remove the nut and bolt and then take these sections apart. So as a reminder, the lower wooden dowel will reach all the way up to halfway point here, and then the second half of the wooden dowel will reach the rest of the point, connecting staff 7 and neck 1 together. I know it's kind of hard to imagine that without visuals, but just play it back and then you should be able to understand. All right, moving on to the head. This is also going to be very intensive, so pay attention. This is an insane build, so there's a lot of steps. I'm gonna go ahead and turn some of these parts invisible now. All right, this is head 1A. All the head 1 pieces will connect radially, and pretty much as you can see by how they are 3D modeled, it's pretty obvious to see which side you're going to be laying flat against the 3D printing bed. That aside, as far as assembly goes, you're going to want to print all 6 pieces ahead of time, connect 3 pieces together to make the half, connect the other 3 pieces to make the other half, and then at that point you will bring them together. On the other side, you will have the head 2 pieces, head 2A, head 2B, and so on. These pieces should be able to print without any supports, and assembling them onto the head 1 pieces are relatively easy. Now, to connect the head 1 and head 2 pieces, you're going to 3D print these little pegs. You're going to print quite a few of them. It's pretty easy to count how many you'll need to 3D print. The tolerances are pretty loose, but that's okay because you're going to be using a lot of glue to attach them. As a side note, I recommend using a much cheaper glue like clear Gorilla Glue in order to just pretty much slather on this surface and then just slap these pieces on. For the center of the head, you're going to need this big peg right here, and this right here is the center of the head. This particular piece is quite large as well, so you're going to need a medium-sized 3D printer at the least. Okay, now I'm going to explain the motor adapter. First, I will quickly turn these all invisible. The motor adapter comes in 2 pieces, and it is designed to fit those particular flange couplers that I showed you. Now, this right here is the motor adapter piece number 1, and this is the motor adapter piece number 2. Piece number 2 is a little more complex, but that's only because of the tolerances required. As you can see, the flange coupler will be able to fit almost perfectly into this hole section here. And then these 6 radial holes will be there to allow for the use of M3 bolts. The M3 bolts will go in through this side. They will thread through the threads of the flange coupler, and then you will apply the M3 nuts on this other side. Now, the way to do this is very specific. What you will need to do is feed this motor adapter 2 over the metal shaft of your motor. After that, then you will affix the flange coupler onto the metal shaft of your motor. At that point, you can apply the JB weld, but you still have the option to apply that afterwards. Pretty much you want to make sure that this motor adapter 2 is fed in between the flange coupler and your motor shaft. At that point, you will then attach the motor adapter number 1. And then at that point, you'll want to apply your JB weld while everything is nice and tight, and then pretty much fuse the metal flange coupler to the metal shaft of your DC motor. Now, as you can see, there are also these 6 holes on the edges of the motor adapter number 1. And if we look back at the head 1 pieces, you will see that it fits right into those holes. Now, this is very important. I highly recommend that as you are doing the dry fits of the head pieces, I recommend you fit this motor adapter 1 piece over the pegs of your head 1 pieces. That way you have all the tolerances correct and all the fittings correct, at least before you apply your glue to all these chunky pieces and then everything's set. Now, before you slather this whole assembly with epoxy resin in order to seal it in place, you can do this next step one of 2 ways. You can have the motor adapter and the flange coupler and your motor, all that assembled and set in place, and then slather your epoxy resin, let that cure, and then you shove that whole thing into this hole, and then feed the wires through, do your soldering, do everything like that. That's kind of a hassle. Or you can put your DC motor into this hole first, solder the wires to that, feed the wire all the way down, and then assemble the motor adapters onto your DC motor, and then do the fitting of this whole thing onto that. It's all going to be a hassle. It's all, you're working with like big chunky pieces, so it's going to be a pain. Also, this is another very important note. Once you do set your DC motor into this hole, be sure to solder all of the wires and feed that all the way through this channel down here. And then while the DC motor is there and you have your wires fed and the wires are soldered to the prongs of the back of the DC motor, be sure to apply some epoxy resin into this hole. That way, once you do set your DC motor in there, it will touch the epoxy resin, and then once it sets, that DC motor, the chassis of it, not the actual spinning rod, will be set in place. Because with the whole spinning head, you don't want the DC motor, the whole thing itself, to spin as well. You want it to be like the interface between the 2 frames. The frames of reference being the head and the neck. And finally, once you get to the stage where you have the head assembled and the neck assembled and the staff assembled, you will have the head and the neck all attached together. And then your staff sections will be attached together. They will be separate. So you got your head plus the neck, and then separate pieces, you got your staff. Next thing you're going to need to do is assemble it upside down. I've 3D modeled a special stand for Specter the Unchained's weapon, because assembling it normally, you're going to need a second person. And it's just so bulky and so heavy on one side that it's really too complex to just do that way. So I will include the 3D models for the stand. You will just 3D print the stand, glue the chunks together, and then pretty much like that's pretty much, and then you'll just set the head on the stand, and then the neck, and then just attach everything together. So that's pretty much how that's gonna work. Even though I decided not to save the plasticity file for the stand, I do have the 3D models, and pretty much the way the 3D models are oriented is how the stand is going to be assembled and oriented. So here's stand section 1. This is pretty much the part where the head is going to lay onto. Here's section 2. This just connects the next section to that section. And then here's section 3. This will sit on top of the previous section. And this is essentially, and this notch is essentially where that back head piece is going to lay on top of. And then finally, what you're going to need is this ribbon clip, because you're going to apply that to your little fancy blue tassel motherfucker. It's just a simple 3D model. I'll just toss it in. Alright, my mouth is so dry. But yeah, that's pretty much it. I try to go as in-depth and in detail as I can. I am reprinting it for a friend, but it's not quite finished yet. I want to get this video out because I am very, very busy with other projects right now. Right now, I'm still 3D printing Bagpipe. I've got only a few other pieces left to go. And so, yeah, very busy because it is con crunch time. Thank you guys for watching. If you like this, go ahead and like and subscribe. Go ahead and check out my CG Trader, Instagram, and Patreon account if you want to support me. Anyway, see ya!